so you've finished your model and worked out your UVs and textures. In this tutorial, we'll work on rigging your item and painting a mask for Unity. Let's get started with rigging. What is rigging? In wider CG contexts, rigging is a term used to describe the process of preparing a character for animation. This involves binding meshes to the digital skeleton and creating controls for animation. For our uses in item creation, rigging only involves the binding step. The Zepeto avatar uses mesh objects and a digital skeleton to be able to move. Parts of the mesh are told to follow the movements of certain bones on the skeleton, and those bones move to animate the character. The rigging process serves to supervise assigning vertices on the mesh to the bones they need to follow. To bind a mesh to a skeleton, we'll have to tell the mesh how to follow the bones. This is done by assigning an influence value to a vertex as to how much it should follow the movements of a bone. These influence values are often called weights. Using Blender's rigging tools, we will do our best to properly assign weights to our item so that it moves with the Zepeto avatar in-app. The Zepeto skeleton is set up with a set of scale bones following a set of corresponding non-scale bones. The scale bones serve to handle body shape deformations, while the underlying bones serve to handle posing and animation. When the avatar moves, the base bones will do all the motions for the poses, while the scale bones follow the base bones while set at a certain size. Item meshes are rigged to the scale bones so that the item will move with the Zepeto avatar while retaining body shape options. Editing weights will largely occur in weight paint mode. Using the mask object as an example, let's take a look at weight paint mode. With the mask object selected in object mode, switching to weight paint mode changes the tools displayed in the toolbar and changes the colors of the mask mesh. In the Properties menu, under Data Properties, we can find a list of vertex groups. Clicking through these groups, we can see how the mask's vertex groups are bound to the skeleton. When looking through vertex weights, we can see how weights are displayed and distributed on the mask. In Blender, weight values are displayed as colors in this mode. Blue represents a weight value of 0, and red represents a weight value of 1. Green represents a weight value of 0.5. During the rigging process, we'll manipulate these weight values using the weight painting tools provided. The Draw Brush tool allows for direct assignment of weight values with a brush and is used to add or remove weights to the vertex group. The Blur brush is used to blur or smooth weights of and between vertex groups. The Smear Brush tool can be used like the Brush tool to smooth out weights, but it can also be used to push or move weight influences around on the mesh. Before we actually get into painting the weights, we need to do a bit of setup for the item and armature, so we'll get out of weight paint mode and into object mode. Let's take a look at the item. Make sure the item doesn't have an active mirror modifier or other deformer modifiers. For rigging, we want to make sure that our model is in a state relatively similar to what we expect to export. The rigging process can be time-consuming, and we don't want to do the same work twice because something big changed on our item's mesh. Now, let's check the armature object. If the item was modeled in an A pose, the skeleton that we're going to rig should be in the same pose. If you modeled your item in the default T pose, feel free to skip ahead. Blender's system for rigging binds the model to the rest pose of the model. If the item is modeled off of a pose other than the default T pose, we could change the item model to fit the T pose, or we can simply alter the rig to allow the item to be bound correctly. To preserve the original rig's T pose, I prefer to make a duplicate of the Creator Base Set rig. In the 3D viewport window, in Object mode, I'll select the Creator Base Set armature and the mask object and make a duplicate using the hotkey combination Shift-D, or by going to the Object menu in the 3D viewport and selecting Duplicate Objects. I tend to put the two armatures in their own collections, so it's easy for me to disable one or the other. I also prefer to include a pose at the end of the duplicated set's object names to make them easier to find in a menu. I'm going to assume that the armatures were given an A pose covered in the modeling tutorial, with the shoulder bones rotated by -7.5 degrees on the z-axis and the upper arm bones rotated by -40 degrees on the z-axis. Hiding the original Creator base set armature and mask, select the new armature and enter pose mode. Check your armature's pose to make sure it's properly aligned to the pose from your item. To make sure the mask's weight bindings follow the new pose, we need to apply the armature modifier to the mask object. Switching back to object mode, select the mask object. Find the Modifiers tab in the Properties panel. Under the Armature modifier, click the drop-down menu and select Apply, or use Ctrl-A while your mouse is over the modifier to apply it to the mesh. The mesh is now set in our posed position. With the A pose applied to the mask, we can apply the A pose to the armature. To apply the rest pose to the A pose, we'll select the A pose armature and go into Pose mode. Select all bones, go to the Pose menu, Apply, then click Apply Pose as Rest Pose. This will set the armature's rest pose in the item's pose position. This allows us to effectively bind the item to the armature in A pose. Once the armature's new rest pose has been applied, return to object mode. We can easily attach the posed mask to the posed armature by adding back the armature modifier. With the mask selected, go to the Modifier tab. Using the drop-down menu, add an armature modifier. Under the Object menu drop-down, find your posed armature and select it. The mask will be rebound to the posed armature, retaining its previous weight assignments, but to a new rest pose. Test out the new bindings in the armature's pose mode to make sure that everything was transferred correctly. With the proper rest pose set, we can now bind the item to the armature. Select your item, then the armature. Then go to the Object menu in the 3D viewport, select Parent, and Armature Deform with empty groups. This will parent your item to the Creator base set armature, attach an armature modifier to the item and point it to the parented armature, and create vertex groups to bind the weights to the item model. Vertex groups are mesh data blocks that store data in groups of vertices. We can view the list of vertex groups on our item by going to the Object Data Properties of our item and looking under the Vertex Groups drop-down section. Blender can use vertex groups for a variety of purposes, like for selective application of certain modifiers and constraining simulations. They are also used to assign weights to bones. If we look at the naming of the vertex groups in Properties, you'll notice that these vertex groups correspond to the bone names in the armature. These are the vertex groups we'll use for rigging bone weights. During the parenting operation, we used the Empty Weights option. This created all of the vertex groups for the item with no weight data assigned to it. As our item is now, it won't follow the skeleton when the bones are moved around. To remedy this, we will have to assign the weights ourselves. Luckily, we have a weights template of sorts in the form of the mask object. The mask object has influence weights already applied, and those weights are the same as the ones applied to the default Zepeto avatar. We can easily transfer all the correct weights from the mask to our item. In object mode, select the mask object, then shift-select the item. This makes the clothing item the active object, highlighted with a brighter selection outline. We can now switch into weight paint mode. In the Weights menu, select Transfer Weights. Expand the option menu at the bottom left of the viewport and change the Source Layers selection from Active Layer to By Name. The Destination Layers Matching dropdown should be changed to All Layers. You may see some colors appear on the item, depending on what vertex group is selected. This is expected behavior and can show that the weight transfer operation is working. The vertex mapping default of nearest vertex is a solid option, but alternative methods can get you smoother results from the get-go. Experiment and see what option is best for your item. The mask's weights have now been transferred to your item. Now we have to check and correct our item's new weights. Let's check the weights on our model. We'll have to switch back to the armature's pose mode to move joints around. So we'll pop into object mode, select the armature, and go to pose mode. Find a bone that should move your item. This bone shouldn't have scale in its name, as these bones do not get rotated in the app. Select the bone and rotate it to some position. From here, we can check if the mesh is appropriately following the bones. If we want to change how the item follows the bones, we should change the influence weights on the item by editing them with weight painting tools. To do that, we'll have to go back into weight paint mode with the item. In our list of vertex groups, find and select the vertex group with the name of the rotated bone. If the vertex group doesn't have any weights assigned to it, they are probably assigned to the corresponding scale bone. In this case, we should select the scale bone vertex group instead. Now we can see the weight influences. To change these influences, we will use the weight tools. But before using any of these tools, I recommend going to the Options menu in the top right of the viewport and toggling on Auto Normalize. This setting ensures that the paint operations will add and remove weight influences from vertex groups as we paint. Selecting the Draw Brush tool, I can use this brush to add weight influences of the selected vertex group to the item. This brush directly applies a weight value, shown here, with a strength per brush stroke, shown here. The default brush strength of 1 is often too extreme for my liking, so I'll reduce the brush's strength to something like 0.2. This allows me to make more gradual changes across multiple strokes. To remove some of the bone influences, change the brush from Draw to Subtract by clicking on the brush selection and selecting Subtract. I can also select the vertex groups of adjacent bones to edit their weights. By adding or removing influences in these vertex groups, I can fine-tune how my clothing item moves with each bone. To blend together weight values, I'll use the Blur Brush tool. This brush will do its best to blend the vertex weights with the weights of nearby vertices. As with the Draw brush, I tend to reduce the brush strength, so changes are made more gradually. The Blur brush can be very useful when trying to make the item's bends feel a little softer. The Smear brush is a tool that I like to use in Blender weighting. The tool takes the value of the weight under the brush at its start point and tries to blend it with the weight value at the brush's end point. This tool makes the weighting process more like pushing weights around, as opposed to directly applying weighting. It feels more intuitive to me, but you may not prefer this method. Using the Smear tool has the added benefit of reducing the chance of accidentally painting vertex weights on a different part of the mesh that may have been in the background. If a bone's weights are in a good place, we can test out another bone by going back to the skeleton in pose mode, picking another bone, and rotating that into place. To reset the rotation of a bone, select the bone, go to the Pose menu, then the Clear Transformations submenu, and click Rotation. This will clear the rotations of any selected bones. Using the Weight Paint tools, apply and adjust weights to fit the skeleton's movements. Rotate bones into more extreme poses to see if the item bends with the mesh properly. If the item mesh looks off, Adjust the weights of the deforming bones so that the item fits the pose. Now, just continue testing out bone rotations until the item's bends are acceptable. This process is very iterative and can be time-consuming depending on your item. Be patient with your item and yourself during this process. The weight painting for this example took a couple of hours just for the skirt. A few tips of what to look out for while rigging. Look out for areas where the mask pokes through your item when it bends. This could mean that your bone weight borders are distributed too softly. You can try and fix this by adding stronger weights closer to the bend point. Ideally, the avatar's skin will be hidden through the masking process, but correcting these weights to fit the weights on the mask can help make your item bend more naturally. Take your test poses bit by bit. While big errors may show up at the extremes of a pose, it can be easier to weight paint on a less extreme pose. If your item is really giving you a tough time, consider making changes to the item's mesh to make life easier for yourself. If your item has multiple layers, consider giving those layers more space to move around each other. If a bend point looks too rough, consider adding more edge loops. Just keep in mind that edits that change the poly count of your item can change your UVs, so your textures may require revisiting. Now that the weights are set, we should bring the item back to the T-pose. We'll do this by transferring the item mesh from the A-pose armature to the original T-pose armature. Bring the A-pose into T-pose by rotating the arms and shoulders back into T-pose. For Zeppeto's standard A-pose, the shoulders should be rotated by 7.5 degrees on the Z-axis, and the upper arms should be rotated by 40 degrees on the Z-axis. Select the item in Object mode and go to the Modifiers tab in Properties. While the item is posed in a T-pose, go to the drop-down menu of the Armature modifier and click Apply. Now, reassign the Armature modifier to the item through the Add Modifier menu. Point the modifier to the original T-posed armature by selecting the context space of Object and find the Creator Base Set armature. Unhide the T-pose mask and armature and hide the A-pose mask and armature. Test the weighting of the item on the T-pose. Now that the item is moving with the original Creator Base Set armature, test out the weighting and rigging to make sure the item is bending as you'd expect it to. You can also go into Edit mode for your item and edit parts of the rig that may have unexpectedly changed shape after the rig transferring process. With T-pose corrections completed, we've finished rigging our item and can move on to masking. Masking is a process where we take the mask object and apply black or white vertex colors on the mask object to tell Unity what parts of the base body to hide when our item is active. We'll use the vertex paint mode to paint the mask black where faces shouldn't be displayed and white where faces should be displayed. After we export the mesh and bring it into Unity, the Unity conversion process will read the black and white vertex color data and disable faces on the base skin layer of the avatar. To get started, select the mask object. Switch to Vertex Paint mode. The model should change to a whitish color. By default, the brush colors are set to white and black, where white is the foreground color and black is the background color. To switch between these modes, you can use the X key or the swap button located in the brush toolbar located in the Tools menu on the right. It's also good to change the brush falloff mode to constant. This type of brush falloff will prevent vertex colors being painted on as gray, as opposed to black and white, which may cause errors during the conversion process. We can change this through the falloff menu by selecting the Custom drop-down option and selecting Constant. This will make the brush flat with no gradation. If desired, turn on X-Mirror so that you can paint the left and right sides of the body at the same time. This helps save time for symmetrical parts of the item. Now, simply paint the mask black where it will be covered by the item. You may have to toggle your item's visibility on and off to check where you're painting. The conversion process will only make faces invisible when all the face's vertices are painted black, so you can feel confident painting the mask right up to your intended border. When the mask vertex paint is completed, you can switch back to object mode. With rigging and masking completed, the item is functionally complete. Give yourself a well-earned pat on the back. In the next tutorial, we'll cover exporting from Blender to Unity and exporting from Unity to Zepeto Studio.